Hey guys, Lisandro here, and today I'm going to do a whiteboard tutorial, and mainly I'm going to be talking about 3D. 3D, and 3D stands for 3 dimension. Now, a lot of you probably already know what this is. Usually the whole deal with the 3D glasses, you've probably gone to a theater and you'll probably get 3D glasses, and probably one side's blue and the other one's red. Y'all have probably gotten something like that. They have it for other stuff. Back in the 90s, they have something for kids meal, something like that with 3D glasses. And there's another type of 3D that 3D imaging that creates some illusion or something like that. But anyway, um, now the thing about 3D is that usually you would have like for example a cube. You get one cube, you get another okay, you get one box, one another, draw it, and it creates the image of a cube. I know I am crappy at drawing at this, but if you look at it um, in different perspectives, a lot of the times the you would think that the cube is facing this way, or if you're looking at a different perspective, it will look like it's facing that way. Either way, what I mean is this: you can't tell if this is the face, this square, or this is the front face. I think you get what I mean. Okay, now the thing is that what is usually referred to is that it's the whole deal with length, width, and height. Okay, those are your 3 dimensions. In a square, it will simply be length and width, and a line just your length. So 1D, 2D, and 3D. Now there's another one that you probably may have heard of, and it's in the hypothetical sense. Um, and let me just draw it here. Okay. And draw here, 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 and here. Okay. And then draw a couple of lines here, couple of lines here, couple of lines here. Okay. So you get the idea. And what this is pretty much resembles what they call a tesseract. A tesseract or a hypercube. A hypercube, okay, which this refers to as 4D. Now, I know my drawing's kind of crappy and everything, but it resembles a cube within another cube. But the real actual deal would be like if you're facing a cube, and instead of getting a face, you would see all the way down like if it was a hallway. You would see all the way down like if it was a hallway, all the way to infinity. That's what hypercube would look like in all 6 of its sides and all. But one thing I want to cover on is this whole notion of what it's like to be in other dimensions. Now, I can show you what it's like, but I can give you an idea. Now, Carl Sagan once said about a book called Flatland. I'll put a video in the description where he talks about it. The video, the video talks about Flatland, and it's a basic description of dimensions. In Flatland, you have get triangles, circles, squares, uh, formless shapes, and infinite amount of polygons um, of different lengths and sizes and colors and anything you can imagine. Well, what it goes by is this. Now, let's say, for instance, this is a not three dimension, but a one, not one, two-dimensional house. And here's a circle. Uh, there's a circle creature. These are all flat two-dimensional creatures. Okay, and what it goes about is this. This creature goes into his own home. Everyone's doing different things. I would imagine they would have society similar to ours, but um, in regards to their own perspective of dimension. Now, the thing is this. This two-dimensional creature gets approached by a three-dimensional creature. Let just for visual purposes, let me make this cube creature to resemble the three-dimensional creature. Of course, Carl Sagan uses an apple as an example. Now, I know this is a crappy-looking apple, no, but he uses an apple as reference. Okay, now this cube talks to the two-dimensional creature and says hello. But the two-dimensional creature does not know how to interact or how to take this, so it assumes must be something in his head or something like that. As to all people who were, well, most people who would say that some things that doesn't make sense, that there must be something wrong with it. That's usually the reaction you will get when someone sees something that they cannot believe. Well, the thing is this. He doesn't like the fact that um, he thinks it's a figment of his imagination. So what he does is that he descends down into Flatland. Now, the thing about three-dimensional objects in a two-dimensional world is that it doesn't have all their properties. So what happens is that um, because this is a three-dimensional creature, he can only display so much of himself. Okay, so only a cross section uh, of the cube is visible within the two-dimensional terrain. So he descends down and into this house of this two-dimensional creature, and he starts seeing, as he descends down, he starts seeing the object's cross section, starting from the bottom face all the way to the top face, transition downwards. And to the two-dimensional creature, this seems like a multi-shape creature. Of course, in a cube, of course, I'm using a uniform cube, so it wouldn't look that different, but it will probably be transitioning. I think Carl Sagan's apple would be a better example for this, since the cross sections change and everything. The example he used, he stamped the apple in an ink pad, but that's not the point in this case. Well, what happens is that the creature gets freaked out by this strange phenomenon being. So what he does is that this creature takes this uh, takes this two-dimensional creature into the other dimensions, which is up and up and down. Okay, and remember, height is not a property here. Height, up, down are non-existent in this particular dimension. So, so because the fact that, well, I jumped to conclusions to say they're non-existent, but the thing is that he takes it. Basically, the how the story goes, this this three-dimensional creature the takes this two-dimensional creature into 3D land. And the thing is, in 3D land, he doesn't know what to make of it because he's never been in a three-dimensional world. He's only been in a two-dimensional world. So when he comes back, he runs off and tells all the other polygon creatures, triangles, circles, smaller and bigger than him, and all formless shaped creatures that he has seen 3D, and tells them about this three-dimensional creature. But of course, they don't believe him because they think he's seen too much and everything. And this goes to show that of course, if we were to say something unbelievable, a lot of people wouldn't believe us. They would think something otherwise. So the point that I'm trying to make here is that the perspective which we see 3D and the perspective of what we see in each respective dimension is very different. The only reason we're able to see objects, like let's say a bottle in 3D, is because of the hues and contrasts and shadows and other facets of this of the objects we see. Of course, but the thing is, the way we see things, it's in a 2D sense. Okay, so so basically, let me cut to the chase a little bit here. Okay, so let's say reality and the view. Okay, reality and view. Okay, so let me make a chart here. Um, Kind of fucked up looking chart, but let me make. This is just for demonstration purposes only. So let me go ahead and start in this midsection with a couple of dimensions. So 3D looks like 2D. Okay. Now 2D looks like 1D. And why is this? Because in 2D we see things have. This is not including the individual hues and contrasts we see three-dimensional objects, but we are only able to see in um, in length and width, or actually length and height. We're only able to see two aspects in two. We're only able to see it in two dimensions. That's why we see everything in two-dimensional perspectives. Of course, not considering the individual hues and contrasts and all. In 2D, if you were in a 2D dimension, you will only be able to see one perspective, and that's the length. You would see things in a straight line, whether they're straight lines or non-existent straight lines. That's all you would see, and colors. That's all you would be able to see. See, of course. And in 1D, and this is a perspective. What goes here? If 1D is the proposed concept of the lowest dimension. But hypothetically, that isn't true. Hypothetically, there is a zero dimension, and we'll propose a zero dimension that would look like a point. That would look like a point. Everything you see, it's a point. Of course, I can't visualize it here because the point has two dimensions. But the thick, because it has thickness, length and width. But it would be an infinite point, point into the nothingness. It would be there will only be either that direction or this direction. There would not be like any side directions, neither up or down. There will only be forward or backwards. Okay, there will only be forward or backwards. So this direction or this direction. Okay, that's the zero dimension. Now, it boggles the mind if there are negative dimensions, negative dimensions from there, because that's beyond uh, what we can pretty much imagine with our mind. And imagining other unknown dimensions is kind of like telling you to imagine a new color, a new color that's not in anywhere to be seen in the spectrum of any sort. Is kind of telling you a new color that's never been seen. And what I mean by new color, I'm not talking about a new shade of green or a new shade of yellow or a new shade of any of the known colors. I'm talking about showing a color that you never seen before. That if you were to see it, you wouldn't be able to describe it because you don't know what it is. You don't know what a new color is. Of course. Now let me get back to the perspective of dimension. Now that goes, of course, 4D would look like 3D. Okay, by this reasoning. But the thing is, 4D, the fourth dimension is debated because there's people that think that the fourth dimension is time. It goes into the debate that time is non-existent and so on. Which personally I don't, I can't claim or anything. And 5D would be the whole notion of 4D and so on. It goes on to perpetuity. And if you go on to consider negative dimension, it will go on to perpetuity and so on. Okay. The thing is that it's kind of hard to imagine these little perspectives when it comes to dimensions, and we're not even remotely close to anything like that, exploring other dimensions. What I mean by other dimensions, I don't mean other universes or anything like that, like it includes in cosmology. Is these is basically the properties of reality, the reality we live in, and we don't even know how to even approach to go into a two-dimensional world or a three-dimensional world or anything of the sort, should it said that such a thing exists and all. It's the same thing for time. How do we even control or approach time? Now there's the whole deal with gravity affecting time, but that's something that's also still debated. Still, well, not necessarily I would say debated, but that's still something that some things that are pretty much unclear and everything is these variety of different theories and all. But one thing, before I go, one thing I want to say about theories: theories are not just guesses, magical guesses that you just say that this is this way. I guess this is way. No, these are I want I don't want to say educated guesses, but these are much more propositions to what could be likely and what could be possible, and the explanation stands until something is proven otherwise or a better explanation is offered and all. But pretty much that'll be all for now that I'm gonna cover, and I hope I'm not forgetting any other details of the sort. Oh, and by the way, I bought an Oculus Rift. Well, not an Oculus Rift, but one of the other competitor 3D goggles, and I'll be getting it pretty soon. But pretty much this will be all for now, and I'll bring this video to a conclusion now. So please like and subscribe, and I'll catch you guys next time. Bye.